Welcome. This lesson is Unit 8, Day 3. It's talking about how to apply trigonometric functions, sine, cosine, and tangent, into the unit circle. In the previous lesson, we learned about the unit circle, how to navigate around it, how to get degrees, and how to rotate left counterclockwise and clockwise and get certain coordinates from that. Today, I'm going to tell you how the sine, cosine, and tangent relate to those coordinates in degrees and radians. Before we do that, I want to show you how to create your own unit circle in case you're not able to print one out while you're doing these notes, or when you take an exam or any test, typically you're not given a unit circle to work with. So you can make one the following way. First, start with your x and y axis. Just draw a quick vertical and horizontal line. Now, make the best circle you can. It doesn't have to be perfect, but you do want it to be somewhat good so you can mark around it. It's got to be fairly large. Obviously, I can do better, but I'm not going to worry too much about it. Next, make 3 lines equally spaced, starting about a third of the way, halfway, and 2/3 of the way through each quadrant. So you want to do something like that. Again, it doesn't have to be perfect. You just want to get the general idea. And I'm purposely not printing one out now because I know a lot of you don't have a printer readily available, including myself right at the moment. And this is a little bit more practical for those people. If you do have a printer and you find a printed out unit circle or blank one you can fill out, then by all means do that right now. So what I want to do is I want to mark the degrees first. So I always start with 0. I count up by 30 degrees. I'm going to put the degrees inside actually. So 0, 30 degrees. And then 60. I'm skipping the middle ones. Add 30, 90. 120. Skip the middle ones. 150. 180. Counting up by 30s. 210. Skip the middle one. 240. 270. 300. 330. And of course, all the way around is 360. Next, let's do the middle ones. The degrees are halfway between, so halfway between 30 and 60, or you could just add 15 to 30, 45. They're all going to end in 5, by the way. So 120 plus 15 is 135. 210 plus 15 is 225. And 300 plus 15 is 350. You get all your degrees. Now let's talk about the radians. For my class, I'm not really in a memorizing position with radians. I like to get them using the calculator. So if you have a TI-84, you can just take your degree and divide by 180 and put a pi on top. Let me show you there without that glare. 30 divided by 180 is 0.166 repeating. And if you press math, enter, you get 1/6. That's 1 pi over 6. So I'll write pi over 6 radians. I don't want to do that with my TI-84 calculator, so what I'll do is I'll just do Desmos for each one, and you can do that too. So if you do all your degrees using Desmos, you can just take 45 divided by 180, and then hit the fraction bar, and there's pi over 4, 1 pi over 4. 60 divided by 180, hey, you can change that number on top. So that's 1 pi over 3. And then 90 divided by 180 should be pi over 2. $120. 2/3, so 2 pi over 3. 135, 3 pi over 4, 150, 5 pi over 6, and then 180 divided by 180 should be 1, right? So that's 1 pi, and we just write pi. So 0 pi, which is 0 degrees, on the right side, and then 1 pi, or just pi, which is 180 degrees on the left side. And then keep going. Again, if you keep retyping the whole thing in, if we do 210 divided by 180, it'll give you a decimal. Just hit the fraction button here, and that'll convert it back to a reduced fraction. So 7 pi over 6. I personally would, now that I just discovered I can retype the number on top, it'll leave that as a fraction form. So 5 pi over 4, 240. 4 pi over 3. 270 is 3 pi over 2. I know that much, but just to be consistent, I'll type that in. 300 is 5 pi over 3. 315, 7 pi over 4. 330, we're almost done with these. 330 is 11 pi over 6. And then 360 divided by 180 is 2, so that should be 2 pi. And that'll conclude all your radians. Now, guys, if you're in a class where you have to memorize those, then obviously this wouldn't work, all right? And so I would refer to the other video that was shared, Ms. Kranish made it, to how to memorize those radians. These are how to get the degrees and radians. Now, as far as the coordinates go, a lot of patterns, a lot of symmetry, but basically this coordinate over here would be 1, 0. This coordinate up here is 0, 1 because it does not go left or right, but it does go up. This coordinate down to the left is -1, 0. This coordinate down below is 0, -1. If you look at the patterns, notice that these y values change signs and these x values change signs since they're going 180. Now, as far as the other 3 coordinates, I like to do remember they're all over 2, so and the pattern being 3, 2, 1, and then 3, 2, 1. And remember that they all get a square root except the 1 on the top numbers. So the square root of 3, the square root of 2, the square root of 2, and the square root of 3 all get square roots. So if you remember those 3 coordinates, okay, square root of 3 over 2, comma 1/2, square root of 2 over 2, comma square root of 2 over 2. Those are the same number because that's 45 degrees, so that's x and y are the same value. And these 2 are just switched. And then you can kind of get all the other coordinates because really this is just symmetric. So this is going to be the same coordinate because the y value is the same. It's just that the x value will be negative because it's in quadrant 2. So this is quadrant 1, everything's positive. This is quadrant 2. The y values, or the x values are negative. So same coordinate here, but negative square root of 2 over 2, positive square root of 2 over 2, because x is negative. Same coordinate here, except this is negative. So negative square root of 3 over 2, comma 1/2. So you got all the top coordinates, and then the denominator, or the bottom coordinates are going to be symmetric along here. So this is going to be the same coordinate as this, but everything's negative since it's in quadrant 3. So negative square root of 2 over 2, negative square root of 2 over 2. Switch these, so negative 1/2, negative square root of 3 over 2. And then finally, to get the coordinates on the right, these are just symmetric. So this is going to be positive 1/2 negative square root of 3 over 2. So in quadrant 4, only the y values are negative. So that's negative square root of 2 over 2, negative square root of 2 over 2. And the last one, this would be square root of 3 over 2, negative 1/2. So that's my way of doing the unit circle, and it's certainly similar in some ways as far as getting the degrees and maybe even some of the coordinates. But I do want you to understand that for me personally, getting the radians does not have to be memorized. You can use a calculator to get those fractions, and just remember to put pi on the top of all those fractions.